What's up, my Rust homies, and welcome to another video. Today we are talking about traits in Rust. If you come from another programming language like Java or even Python, you can think of traits as a sort of interfaces or abstract classes. Basically, traits are a block of code defining a certain behavior proper to different types like struct or enums. A behavior's type consists of the methods that we can call on it, so different types share the same behavior if we can call the same methods on them. For example, let's say we are playing an RPG game in which our avatar can use some artifacts and they are rendered in the game in their own unique way. So, we want to code a rendering mechanism which allows us to display different types of artifacts, such as weapons or armories. So now we are gonna write our first trait implementation in Rust. So let's write trait render, and then in curly brackets we're gonna define the behavior, which is a function render. Just like that. As you can see here in the function there is no block code inside curly brackets, so here we declare a trait using the trait keyword and then the name. And we declare basically just the method signature that describes the behavior of the types that implement this trait. Then we end the statement with a semicolon without writing any code, because each trait implementation will have its personal version of the render method, and this will be enforced by the compiler. Of course, a trait can have multiple methods to implement. Now we can implement this behavior on the types we want, so let's define two structs. Let's say we want to have a sword, so we are going to create a struct sword. And this will have as fields a metal, because of course the sword is a metal one, a damage, and then a boolean flag which tells us if we can use this sword with two hands or just one hand. And then we are going to have a potion struct, and of course the potion has a description, which is a string, a duration, because after some time the effect of the potion vanishes, and then a list of the ingredients. So these ingredients will be a vector of strings. Okay, so far so good. First of all, let's implement the trait for the sword struct. So we're gonna write imp, which is the keyword for implementing a trait, then the name of the trait, and then for sword. We see that the compiler tells us that we have to implement the missing members, so of course we're gonna write our definition of the render function, and we are just gonna print some information about our sword, so forging sword forged, and then the properties, which in this case are the metal, the damage, and if it's one-handed or not. Okay. Now we are gonna do the same thing for the potion struct, so imp render for potion, and this will basically has the same behavior, so we're gonna add the missing member. So println, and we have a description about our potion, so cooking potion, your potion is ready. Then we have a description, a duration, and a list of ingredients. So, oops, here we have description, self.duration, and then we're gonna list our ingredients, so for ingredient in self ingredients, and we're gonna write our ingredient. Okay, nice. Okay, now let's test this new feature in our main function, so I'm just gonna paste some code. What's about that? Missing struct field description. Oh, I have a typo here. It's not description, but it's description. So let's change this. Okay, and here we have string from, because of course these are string and non-string slices. So string from, and then string from. Okay, now it should be okay. So let's format this. Okay, let's run the main function. Cool. So here the compiler prints some information, cooking potion, your potion is ready, then we have the description, the duration and the list of ingredients, and the same thing for the sword. Cool, guys. So as we have seen, we can implement traits on types with the impl and the for keywords, and sometimes it's useful to have a default behavior. For example, we could have an unknown artifact that we have acquired, but we still don't know how to render it. So we can actually write some code inside the trait block. So we're gonna write something in the render function, and we're just gonna print you have acquired a mysterious item. Ooh. And this will be the default behavior. So we can have another struct for the unknown artifact. Oops, unknown artifact. We're just gonna leave it empty, and then we implement the render trait on this struct, and we can leave this empty too. So let's test this feature. We are gonna create an artifact, unknown artifact, and let's render it. So you can guess what is going to happen. Of course, here we have the description for the unknown artifact. So you have acquired a mysterious item. Okay, so far so good. So as you can see, we left the implementations for the other types just like we wrote them before, because the syntax for overriding a trait behavior is the same as implementing it from scratch. Another cool thing about default implementation is that they can call other methods in the same trait, even if those other methods don't have a default implementation. In this way, the default trait can cover the general common behavior. So now we are gonna modify the render trait. So basically, when we acquired an artifact, we are gonna write new artifact acquired. And then we are gonna call another method, which is render artifact. Of course, we don't have it right now, so we are gonna define the signature. And since we want this method to be unique to each trait implementation, we are just gonna leave it empty. Okay. So of course here we have some errors because we have to modify this. So this will be our render artifact. And this will be our render artifact. Okay, we're not interested anymore in the unknown artifact, so we can delete this. And let's see the update. So now we have a new line at each render call because we have acquired a new artifact. So this is the render function actually. So this is the common behavior part. And then we have the original implementations for the different structs. Okay, nice job. So this is it for today. We have seen a nice introduction to traits, and in the next video I'll show you some advanced uses of this nice feature in Rust. So, my Rust homies, that's it for today, and see you on the next video.